Today we have determine if the vector field is conservative. If so, find the potential function. So we're given a vector field, f of xy equals to x cubed plus sine y minus y squared x, and then I plus x cosine y minus yx squared plus y cubed, and then that's our j component. So first things first, I actually like writing this in the vector field in vector form. So we're gonna have these little, whatever these are called. So I'm just gonna go ahead and write down what we have here in vector form. So I'll be right back. So this is it in vector form. So let's label this. Notice how they're the same functions inside and same components inside of the vector. So let's actually go ahead and label these. Let's label this one. You can label them whatever you want, but let's go ahead and label this one right here, M, and this one, N. So let's go ahead and find out if they're conservative. So what does that mean? It means that they will have a potential function such that the vector field is equal to the vector gradient, right? The gradient. I'll go ahead and show that later on, but first let's go ahead and take the derivative of this one, of this component, the M component, with respect to y. This is actually a nice shortcut to determine. It's a small test to determine if these are conservative or not. So when we take the derivative of M with respect to y, that's going to be cosine of y, right? Cosine of y minus 2yx, right? And now let's go ahead and take this component with respect, the derivative of the n component with respect to x, right? So the derivative of n with respect to x is equal to, let's see, that's cosine y, right? Minus 2yx, right? And that goes to 0. So look at these. They're equal to each other. So that's a good sign that the vector field is conservative. So yes, they are conservative. So that means that we have a function f, small f, such that, well, there exists a function f such that the vector field is equal to the gradient, the vector gradient. And I sure hope you guys remember what the vector gradient is. If not, go ahead and refresh your memory on it, but it's not too complicated. It's not that important for this question. So there exists a function. We do have a potential function for this. So now we're actually going to go ahead and find the potential function. So this is yes, it is conservative. Yes, conservative. So it is conservative. So let's go ahead and okay, so now let's go ahead and move on to finding the potential function. So let's go back here and let's choose a component. I'm gonna choose this one. So f of the potential function f of xy is equal to, we're gonna integrate this one with respect to x, because I chose this one, so we're going to integrate this one with respect to, because you can choose whichever one, but I'm going to go with this one. So it's x cubed plus sine y minus y squared x. Let's integrate that with respect to x, and that gives us 4x4 to the 4th power plus x sine of y minus 1/2 y squared x squared. Let me make sure that's correct. 1/2 y squared x squared, okay. And our constant of integration is just going to be g of y. Okay, So now this is going to be a potential function. So f of x, y, just keep that in mind. So now let's go ahead and take this thing that we just integrated with respect to x. Let's take the derivative with respect to y of this function. So we have the derivative with respect to y of the function f of x, y is equal to, let us see, this one constant goes to 0. That is just the derivative of sine y. I mean, obviously the x is a constant, so it comes here. That's cosine y, right? The derivative of, we're just taking the derivative of this with respect to y, just in case if you are lost. So that's cosine y with an x, right? And then minus the derivative of y, that's y, the 2 comes here, cancels that out. So that's negative y. And then we got an x squared here, that's just a constant, so it's x squared. And then this, we take the derivative of y, so that's g prime y. And notice something, look at this thing that we just took the derivative of with respect to y. Look at this, what it gave us. Doesn't this look like the n component? It does. So let's go ahead and set the n equal to this one. So n is equal to x, this is the n, by the way, x cosine y, x cosine y minus y x squared plus y cubed is equal to what we just calculated, or what we just took the derivative of. So that's x cosine y minus yx squared plus g prime of y. Okay, so notice that these are pretty much equal to each other, except for this part and this part. That means that g prime of y is going to equal to y cubed. But we only want g of y, not g prime of y. So I'm gonna take the integral of this. So the integral of that, g of y, you know how to integrate. It's gonna be 1 over 4 y4. So now we're gonna take this and plug that back into our potential function. So let's go ahead and do that. So that's 1 over 4. That's 1 over 4 x4 plus x sine y minus 1/2 y squared x squared plus 1 over 4 y4. And that is going to be your potential function of x and y. So yeah, this is your potential function. The gradient vector, by the way, just in case you don't remember, but it's literally just the derivative of the function with respect to x, and then the derivative of the function with respect to y. That's it. That's all it is, just in case you forgot. So now you know that this is conservative, and we do have a what do you call it? A potential function. Now we found the potential function. And yeah, then that's it. So it's conservative, so there exists a potential function, this one, such that the what do you call it, the gradient that we just had here is equal to the gradient, I'm sorry, the vector field that we just had here is equal to the gradient of x and y. So just take the gradient of this and it should be equal. So yeah, that's it. And if you have any questions, just let me know. Thank you.